We're going to look at simplifying radicals, this time with division. Now, there's one main thing that we're not allowed to have, and that is a radical in the denominator, ever. If you ever see one, we have to get rid of it. We never would leave a fraction unsimplified. We would never leave, I guess, a radical in a denominator. So we have to simplify that somehow. Okay, so taking a look at the first one. Now I see two radicals, but I can also pretend as if it's one giant big radical. They both mean the same thing. It's just two ways of looking at the same idea. Now, if I look at it as one big one, I've got a fraction in there, 6 over 12. Simplify that fraction, 6 over 12. Let's give ourselves smaller numbers to play with. So if I do that, I'm going to get 1 up top, 2 on bottom, and we still have a y up top. Okay, so all I did was make myself smaller numbers. Now, we still have that radical 2, not allowed to have it. So we do something called rationalizing the denominator. We multiply by a value of 1. So I could just multiply by 1, it doesn't change the problem. If I put a 1 under it, I can, if I have a number over itself, it doesn't change the problem. Again, it's still 1. I could change that to 10 over 10, 40 over 40, 40x over 40x, square root 40x, square root. It doesn't matter as long as it's 1 over, as long as it's something over itself. Now, there's a specific number that I want to use, and in this case, I'm using this denominator. So I'm going to multiply by a value of 1, something over itself. When I do that, I can now multiply straight across. 2 times 2 gives me square root of 4. Up top, I'm left with 2y. Okay, well, in the beginning we simplified. Should we simplify here, the 2 over 4? Well, no, because then we're going to come right back to where we started, and we're in this vicious cycle of not being able to get rid of the 2. But something really neat happens when I multiply by itself. Square root times square root of 2 times square root of 2 gives me square root of 4. This is a perfect square, which gives me 2. That's done. Once you take that square root, that house is gone. Up top, I leave what we have. And now, can I simplify this top 2 and the bottom 2? No. One's in the house, one's out of the house. They're two completely different people. We leave them the way they are. And there's no longer a radical downstairs. That's all I care about. Okay. What if we have a radical times a radical and fractions with inside? So let's just put these numbers together. 7 and 5 gives us 35. And over 6. Now, we need to rationalize this. We need to figure out, we're not allowed to have that 6. Let's get rid of it. So we're going to be dealing with some numbers now. We're going to do some work. So I look at the denominator, and that's what I multiply by, that over itself. On the bottom, I'm going to come up with square root of 36. On the top, we got to do a little bit of work. What's 35 times 6? 35 and 6. We got 30, 18, 19, 20, 21, 210. 210 under that square root. Okay. One of these we can do. We can break up that 36. Square root of 36 is perfect square. So we then say that that on the bottom is a 6. That's our main goal. We no longer have the radical. Up top, though, can I break 210 up? Well, let's find all your multiples, or all your numbers multiplied together to give you 210. 1, 210, 2, 105. Does 3 go in there? Who knows? Let's get a calculator. So I'm going to just keep saying 210 divided by the next number. So 210 divided by 3 gives me 70. 210 and 4 gives me 52.5. I don't want decimals. So we can keep doing this. And I'm going to run through this whole list. So almost done. All right, so 14 and 15 is our last pair. Now, all of these are numbers multiplied together to give us 210. The reason why I did all this was I wanted to see, can I break 210 up into two pairs, into a pair of numbers, one of them being a perfect square, one of them not. Are any of these numbers perfect squares? No, 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 no. All this, sorry, a bunch of useless work. Our final answer, we get that. Uh, can we simplify 2, 10, and 6? No, one's inside the house, one's outside. You leave it. Okay, so that's when you have I guess we'll say a monomial, one group on the bottom. Now we have to do something a little different because we have something new here. We got this is called a binomial. There's two groups here. Okay, so in order to rationalize the denominator, we still need to multiply by a value of 1. But this time, we're going to multiply by something called a conjugate. Now, when we're talking about a conjugate in English class, a conjugate's like it's a variation of a word. We're going to do a variation of this denominator now. So again, multiply by a value of 1, so we need a fraction. We're going to have 2 radical 2, 2 radical 2. The variation here is I'm going to have the same numbers, but this middle sign is going to change. So I see a plus sign, I'm going to put a minus. I'm going to put a minus. Same things, top and bottom, still a value of 1. We're just going to change the way this looks, not its value. So how do we do this? Up top, let's distribute. Let's say 3 times 2 and 3 and radical 2. So we get 6 minus 3 radical 2. On the bottom, it's going to be a little more challenging. Now we got to do a FOIL method. I don't know if we remember this. First, outside, inside, last. So my first numbers, 2 times 2 is going to give us 4. My outside, 2 times negative radical 2 is going to give us negative 2 radical 2. Inside numbers, radical 2 times 2 gives us a positive 2 radical 2. And last, positive negative gives us a negative. 2 and 2 gives us 4 inside the house. Okay? So now, can we combine anything? Yes, we can. Take a look here. We have a positive 2 radical 2 and a negative 2 radical 2. Those things, they cancel out with each other, giving us 0 there. All right, what else? Square root of 4. I know that's 2. So let's rewrite this whole problem. I'm going to have 6 minus 3 radical 2 all over 4 minus 2. So this right here gives us that 2. All right, can we put those two numbers together? Yes, we can. On the bottom, we get 2, and then up top, 6 minus 3 radical 2. Okay, can I subtract 6 and 6 minus 3? No, I cannot, because that radical 2 is stuck there. Not like terms. I can't cut anything in half. I can't simplify these. One's inside the house, one's outside. We're done. No more to go. Now, my last one. I'm not going to do this, but we can set it up. When it comes to rationalizing the denominator, we need to multiply by its conjugate. Our conjugate here, just to get us started, radical 7, radical 2, radical 7, radical 2. We have a minus sign, plus, plus. And now we're going to have to distribute the top, FOIL the bottom. Distribute the top, FOIL the bottom. And that is simplifying radicals using division.